Okay. Hello. We are live. Let me check my audio on my other computer. So it's going to be doubled for a moment. I apologize. I just want to make sure it's loud enough because it looks pretty low on my end. Okay. Let's bring it up. Okay. Okay, it's still pretty quiet. And there's a little bit of the echo. I can hear it. Okay. Um, Here's my audio presets thing. Input, recorders. Oh god. Okay, I'll turn it up on here, maybe. Turn it up on here, maybe. It looks like that's the solution. I'm cranking it really high. It looks like that's the solution. I'm cranking it really high. Put it even higher. It looks like that's cranking it really high. Put it even higher. It looks like that's cranking it really high. Okay. Okay. Boom. I think that looks good to me. Yep, it's dancing in the yellow. Perfect. So, it might be a little quiet coming out, but it's certainly at a point where, you can adjust your own volume on your computer and it'll sound good. But okay. Yeah. Stream idea and I think the title is wrong. Let's set that real quick. Let's do scene 2. Stream settings. Edit. Um Programming. Doing Python. Are there mixing modern mixing 80s computers with modern computers. And then in the description, I'll say connecting to a Commodore 64 with Python on my computer with Python. And yeah, but yeah, that's the plan for today's stream. I've done some research outside of the stream. I've been doing some research on if this is even plausible. It looks like it is. So let me draw a diagram. So, oops, BRB. So, all right, let me show you something, and let me do the audio again on my laptop, just real quick. So, oops, BRB. Okay, sounds good. Give me excalidraw.com. Okay, so let's talk about something. So perfectly, I already have this thing lined up here. So all right, kernel ROM, yada yada, boom. So this is all just data that's in the computer, right? And what this means is that we can addressable with memory addresses. So if you've ever seen stuff that says like, you know, FFAB 06F E 808D, right? These are memory addresses. In this case, the Commodore 64 has a 16-bit memory bus, so it can, use memory. So, interestingly, one way to get data in and to get data out is going to be via the user serial port. So, okay, let's expand our diagram a bit. Zoom out. Okay, so we have data. We know we have data here. It's addressable with memory. Over here, we're going to put our computer. Our computer is going to be, I took a lot of the colors already. Here's our Commodore 64, right? Commodore 64. Oops. Shift. Oh gosh. Link. Group. Perfect. Okay, so here's our Commodore 64. Bam. And we can say purple. We'll say computer. So it can interface with data by sending a memory address over the memory bus. Okay. So here, we'll put it over here. Give me this thing. And similarly, we want one going back. And let's get you down here. Move you down. Perfect. Okay, that's a great little memory bus. Noki, the memory bus should be white because we're distinguishing with colors. All right, let me label that memory bus. Okay, so we can send a memory address over the wire and it'll come back. Okay, but what if we want to interact with the outside world? Well, we have a couple ways to do that. We have the kernel ROM here, right? And kernel stands for like keyboard something something. And let's look at what does kernel stand for? What does kernel mean? Computer. Because I know that it used to like stand for something. It was a little mnemonic. Say kernel. Okay, kernel like that is not anywhere. Okay, what is kernel? Man, I know this was in the manual. What does kernel stand for? Commodore 64. Kernel, okay, it's not real. It's a backronym, and it's actually a famous misspelling. Keyboard, entry, read, network, and link. Okay. But yeah, so we can use the kernel to like interface with the outside. But what if it's not linked to the kernel? Well, we can do with something called a memory mapped device. So over here, let's put our device. Let's say this is over here. We have a network device. A network device. Or another example of this, like a real world example of this, actually, is going to be like the graphics chips on, say, an NES, like the PPU, and on the Commodore 64 as well, right? Like these are memory mapped sections of memory that map actually to an external device. So, and in the network device, it actually has like little chunks of addresses. So we have a couple addresses over here. So like let's put a couple like read, write, and like so let's say these are the memory areas, and this is a weird design. So here we have like the data buffer, and let's say it's like 1 kilobyte of data, and then we have like a status byte, and we have a control byte too. Control byte. Okay, so let's compare. Let's look at a program real quick. So, all right, I'm gonna type it in the Commodore 64 because I don't have anywhere else to put it. Or actually, ooh, you know what? Wait a second, because I'm gonna write some assembly out for you guys real quick. Yeah, Supermon 64. Oh, beautiful. We can do some assembly programming. Heck yeah. Load. Uh, star 8 1. Searching for star. Found it. Run. Okay, boom. So we have our little program here. I forget the commands. Shoot, let me look it up. Supermon 64 usage Commodore 64. Oopsie daisies. Yeah, okay. Okay. Supermon 64. All right, I want like a usage instruction. Display the register. Simple assembler. Okay, so let's write some assembly. So we're gonna, and you know what? Here, I'm gonna adjust my. I'm gonna mute for a second because it's gonna be loud. But I'm gonna adjust my keyboard, and I'm gonna like move it up. Okay, and by move it up, I meant literally like they're on little tripod things, so they can be like lifted up and like raised. And I'm sitting on the ground, so it's much more comfortable to do it this way. But anyways, so okay, we can assemble into address 2000. Let's do a little program that just does store into A the number 1. Oh, I don't know my syntax. Oh gosh. Man, am I stupid? Did I forget all of my assembly? Okay, let's do A 2000. I think it's STA. Do I need to like specify this? Question mark. A 2000 LDA. And let's do like 1000 as our address. Yeah, so we'll load 1000 into the accumulator. Here, I need the list of assembly commands. 6502 assembly instructions. Mnemonics. Oh gosh, I'm really displaying my incompetency here, aren't I? Okay, okay. Inc. Yeah, I just want to like increment X. Increment A, I mean. Increment accumulator 6502. Oh, I can't. I have to do it to Y. Okay. Uh, let's do instead LDX address 1000. And then we'll say, or you know what? Here, let's restart. 2000. Let's just do a quick. There we go. Okay. So that's the state of our registers right now. Let's go ahead and say assemble into the address 2000. I went to LDA. Load into X address 1000. I want to increment X and then ST X back into address 1000. Okay, so what this program will do is it'll take the value at 1000, increment it, and then put it back there. So, in fact, we can take a look at this. We can say, I know there's a command to like show, I think it might be V, disassembler, fill memory, go, run, jump, hunt, file handling, load, save, transfer, disk operations, compare. Ooh, I wanna, I want to just print register display okay, it's M. Okay. So we'll say M 1000. So at 1000 is the symbol 9A. So after this program, it should be 9B. Oh, and actually, A 2007, what should it be? Oh God, is it? I think it's BRK. Okay, perfect. Now, all right, so we see, oops, uh, M1000. So you see this. This is the memory at address 1000. So it's 9A. We're going to execute our program at memory address 2000 that we just wrote. It says ready. It says we're done. So then we'll look at 1000 again. Oh, and it exited the whole program. How odd. Oh gosh, it's not execute, is it? That's exit to basic. Go 1000. Oh my god, guys, I'm so stupid. Okay, M2000. Okay, D2000. It might even still have my program there. Okay, yeah. LDX, INX, StoreX. All right, let's view 1000. All right, this is embarrassing. So, okay, so it says 9A. So we'll go to 2000. Okay, it ran it just fine. It returned us back to the prompt. So now we can look at just 1000 again. And you'll see, boom, it says 9B, the very top left corner. We can run it again. Okay, so what we've been doing in this program, is entirely, let me zoom out just a smidge, is entirely in this memory bus here. It's been entirely memory bus like address space. Okay, data in, data out. We put the program in data. Okay, but let's suppose that we want to work with some kind of network device. Let's write a little hypothetical program down here. Or we can put it like over here. And we can call it like memory mapped device program. And honestly, let me zoom into you while I'm talking about it. So the way this will work is, I know, man, I'm so disorganized, guys. What a fool am I? Okay, so memory mapped device program. The way it'll work is we'll like, the pseudocode will be something like set status or read status byte, make sure device is ready, set control byte to send, and that would basically like clear the, what's it called? That would basically clear the control, it would make it so that whatever we're, like, let's say we have a network address in the control byte, right? It would mean that whatever we put in our data buffer is going to be sent to the outputting network somehow, right? It's just a way of interfacing with the device. So whereas before with our program that we wrote, so we do D2000. So we were working with the address $1000. That's like hexadecimal 1000 or 1000. 1000. Yeah, that's 2 zeros. If we're working with it like then we're going to have, what's it called? It's going to be working entirely in here. But we can use the same memory bus to access our network device. Because, like I said, we can use the same like memory bus to access our network device because the network device is memory mapped, which means that we can control it using the same commands. So, so instead of doing something like STX 1000, like this third line in the program there, STX $1000, if it were a memory mapped device and 1000 mapped to something, that means it would do something in the real world. It might send some information, it might read some information back. But either way, it'll do something to the world. And actually, a good example of this is the NES wiki. NES wiki. NESDev wiki PPU. So, yes, I am a person. Good lord. Okay, programmer's reference. So, the registers, PPU registers. So, okay, so the CPU, all it does is crunch data. But it has a bunch of these registers here. Like here, let's zoom in. these registers are memory mapped to the graphics card of the NES. So when you read and write from these registers, like the bytes do something different. It's not just data, but it's memory mapped, which means that you can program it just like you would other programs in the data, in like the data plane, right? You would just type STX 2000, like here. Let's say we wanted to set the scroll, or no, let's say we wanted to set, like, so okay, so this is a PPU status. We read from it, or no, yeah, PPU mask. Okay, color emphasis, sprite enable. Okay, so yeah, so let's say we wanted to disable sprites. To disable sprites on the NES, what you would do is, and we'll do it like 2008. What you would do is say, oh man, is there a way I can load just an arbitrary value into memory? Can I put an arbitrary value in a register 6502 assembly? Oh Lord. Okay, so yeah, it would just be direct mode. So let's say we wanted to turn sprites off on the NES. Okay, we'd have to set this S bit to 0. So let's say I don't care what the other things are. So it'll be 11101111. And let me think what that is. So that's 0. So a full is 15, which means 14. So we want this to be E, and we want this to be F. So here, I'll show you why. Again, this is just binary. So a hexadecimal number like this, it maps to the binary 1 2 3 4 1 2 3 4. So each hexadecimal character is actually something called a nibble. NYBLE. It's a nibble. It's a half a byte. Just a nibble. You know what I mean? So to convert, if you see like a binary number like this, 00110001, well, you can convert this pretty easily to hexadecimal by just separating it apart. So the first one's going to be 1. So we don't know what the second one's going to be. Or rather, I don't know what the first byte or the first nibble is, but the second nibble is just 1. And the other one's just 3. So we can say 3 1. And if we want to, we can keep incrementing. We can basically keep counting up. So 3, 4, 5, 6, 7, 8, 9. And then we switch to letters A, B, C, D. Ooh, I messed up. Wait. Sorry, I skipped something somewhere. My bad. I'm stupid. Anyways, F and E. So suppose we want all the other features on in our PPU register, right? Well, we would just write this little program where we might say STX, and we'll do direct mode, and we want E, EF. What? Oh, not store. I'm a fool. Assemble into 2008. LDX. EF. Yeah, we just want to load that value into X, and then store from X into register. Which register was this? I forget. 2001. Oops. 2001. So that simple program right there, it would interact with the graphics card to, do something in the world. Very useful, very incredible. Using the memory bus to interact with the outside world. I say all this because that's exactly how we've been interacting with with the internet, right? There's actually a user mapped port called the user port that it's mapped to certain addresses and memory and stuff that we can use to do stuff. So I have, let me see, let me load the correct kernel. We're gonna load into the what's it called? Not the loadable kernel, but the standard default kernel like we did last time. Hardware, system ROM standard C64, and I'll also go up here and I'll enable RS232 mode to UP9600. Yeah, that looks good. That's how we connect to the internet. And then we can just reset. And I'll be able to start doing the program. And I'll be switching back between the Commodore and some Python code. So yeah. So I pre-prepared some code outside. So here I can actually here 10 print finding the code I wrote. Uh oh print 20 go to 10 run. Okay, so that's what I forget what it was called. It's in my notes app, guys. I was coding in the notes app for some reason. Okay, so the gist of this program is we have a memory mapped network device by the user port. Okay. Oh gosh. And okay, by the way, this is one of the reasons that the Commodore 64 is so powerful and why I think it's actually worth learning. So like why should you learn the Commodore 64? The big reason here is right here. It's so powerful. You can work directly with memory. Like even in basic, I have commands like this. I can say poke. I can peek a value. Like let's say I want to know what register 0 is. Peek. Peek. Do I have to like put $sign? What? Peek. Print. Peek. Print. Peek. What? What is the peek syntax? Basic peek. Pissing me off. What? Do I just store it? A equals. Oh goodness. A equals peek 1000. Syntax error. Brother, what? What on earth? 10 A equals peek 1000. Run. Syntax error in 10. How is there a syntax error there? What the hell? 10 A equals peek 1000. 20 print A. Run. 0. Okay, yeah. So yeah, I can directly work with memory addresses here. Where was I? This is why the Commodore 64 is so powerful, because even in the very simple basic commands, you can just type in type in little programs that are going to interact directly with memory. So I can say 10, I want to poke the value into address space, into the address 1000, 20a equals peak 1000, 30 print a. So this simple why can't I poke that? Are there no spaces? Yeah, okay, so this simple program right here, it literally goes directly to the hardware, writes the values it needs, and there's no level of abstraction. There's not a single layer between you and the actual memory on the computer, right? In a modern computer, you have all this like virtual memory and this stuff for security. And granted, it's good, it's great. You can't execute arbitrary programs anywhere, but on the Commodore 64, you can just do it. It gives you the power because it trusts the user to be able to actually use the computer, right? Like, I did a bunch of manual streams. In the manual, the only way to interact with the Commodore 64 is via programming. You have like the basic commands that we're running. Like, I don't know if I have a disk loaded, but if I type this, load star 8.1, that command right there that I just typed out is a like program command. Like there's no difference between me typing that right there versus me writing a basic program and writing that as like a command or whatever, as a statement in the program. There's no difference. You're literally programming. The Commodore 64 trusts you. It treats you as an adult instead of treating you as a child who can't handle a computer. And it gives you complete access to all of the low-level stuff that you might ever want at the end of the day. Anyways, that is that rant over. Apologies. Let me make a mark of that timestamp because I might make that into a clip. I've been wanting to make clips to post on places like YouTube Shorts, perhaps. That could be interesting. That could be good. Maybe attract some people. But yeah. So, anyways, the way it's gonna work is we use the user port connected to Wi-Fi, or like as like a modem, as with a memory mapped device. We can use some basic to peek and to poke it. Sorry, I can't find the program, guys. I feel I'm embarrassed. Okay, so all right, I found it. So all right, so on the computer side, we're gonna need a few things. Okay, so we need a way to connect to the so here's how it goes. So we have over here, we have my computer. My computer. Then we're gonna have a virtual file in here. Oopsie. This virtual file. Oh gosh, come on. What? Virtual file. So this virtual file is what we're gonna use as a socket to read and write data. So data is in white. Boom. Boom. And the trick is, this data, this virtual file, it's a virtual file. It's not actually a file, right? It can come outside of the Commodore 64. And it goes all the way over here. Do it in white. Goodness. To the Commodore. Commodore 64. Bam. Bam. So this is the little diagram we're gonna have. And this is gonna be here, the port here is the user port. And this is just over Wi-Fi. And it's actually a virtual user port because we have the Matryoshka doll of what's it called? Of the the Mister and the Counter 64 and all that kind of stuff. Sorry. Getting all of it loaded. Because I might pivot away from the virtual thing. And I think the best way to do this might actually be to go through CCGMS, the system that we used to what's it called? We use the modem directly. So okay, so what we're gonna do is we're gonna do a network listener first. So let's just write a program. Remark network listener program. Oops, I misspelled. So we're gonna start off with this command. Um, get one a $. And this is basically just telling basic what the variable is. If a $, equals, if it's nothing, and the a $, means that the variable is a string, then 20. 30 is print a $, poke 631 ASC a $. So this is a single character that we've stored. And then poke 198, comma 1. And then line 40, go to 20. Okay, so here's what this does. All right, let's go to open. Let's look at the docs for open first. Okay. I wrote the whole program, and you guys couldn't even see it. So 10. So first, we're gonna remark. I wrote this program. It says we have a network device listener program, and this I didn't write this program. Just to be clear, I cobbled together this program from snippets online. I'm not an advanced enough basic programmer, to do this all by myself. The most advanced basic program I've ever written, you guys, it's on stream. I wrote it on stream. It's about to be a video actually. I think by the end of this week, I want to have it done and edited. But every time I sit down and edit, I lose all motivation. But whatever. I'm lazy. That's neither here nor there. Yeah. So this is the program, and let's just make sure it runs. File not open, error in 20. Okay, that's a problem. I thought I connected our enable drive, parallel port, external IEC, enable expansion, RS232. That's what it is. File not open. Okay, maybe you have to reset it now. I don't want to reset it. But what's happening there is it's trying to open up the user port list. Okay, so I'll have to rewrite it. Let's first look at the docs, and then we can explain better what's going on. Commodore, oh goodness. Commodore 64 wiki get. So the basic get command, which we learned from the manual, it gets the information from the keyboard. Goodness. But what if we want to get information from anywhere else? Well, that's why we need the keyword that we were just thinking about, which is open, which is going to open a file. So we start off with devices numbers here. And I want to make sure that it's all set up correctly. So we have hardware. Okay, expansion is RS-232. RS-232 mode is up. I think I need to be VIC-11. Connection internal. UART is TCP. Baud is 2400. Okay, so now we should be able to listen on the network. So, all right, so 10 open, right? Open, and we want logical file number. So it'll be number 1. And you can see here that 1 and 2 are kind of linked. And we use the second number to control it. But dataset / modem is what it's connected to. So we'll do open 1, device number 2. That's device number 2, the modem. Okay. And we want secondary number 0 for now. And then finally, our last little command character is the number 8. Oh, the $sign's in the wrong spot. 8, which this opens the user port at baud 2400. And I think we should be able to just run that program. Yep, okay, so it's able to open a device. So now what we'll do, 20, so we'll say get from device 1. So we just opened the device. Now we can interact with it. We can get stuff from it. Get a $. Say if a $, if we didn't get any data, then just keep repeating. Otherwise, I want to just print the character. A $, is just a string, but we're using it as a character. Print the character, no spaces. And then we'll poke 631 ASC a $. So what this does, address 631 is up here. It's one of our memory mapped devices, and in fact, it's the keyboard. So what we're doing is we're saying, hey, this is the data I'm putting in from the keyboard. And then, so we poke the data in, and then we say, hey, Commodore 64, poke 198 with 1. And what this says is, hey, you've got 1 character in the keyboard buffer. And I'll say 40, go to 20. Okay, so our program is running. It's listening on the, what's it called? It's listening for the on the Wi-Fi on the network. And here I need to make sure TCP baud TCP connection modem, baud rate 2400. Yep, that all looks good. Okay, I don't know what port I'm supposed to connect on. I don't know. And what we're doing is essentially a telnet style connection. But here, we want to go over here now. And we want to go into projects. And we'll make a new directory called Commodore 64 Shenanigans. And we'll make another directory. Call it, I don't know, control from afar. CD control from afar. And I'll zoom in. Oopsies. So you guys can see this better. Okay, control.py. So it's going to be a Python program that we're going to write. And this one I can explain much easier. We'll we'll find out our device's local IP. Okay, and that looks weird. I don't know why it's that. I might actually have to just go to like here. I can find it out on my MacBook actually. Give me Finder because it has the FTP server, enabled. So it should appear as a network device, and I should be able to, goodness, see the address. Maybe by looking at it here. Get info on that file. Kind network. Nope, not showing. Okay. And root 1 is the default Mr. username and password for God knows what reason. Let's actually just here, let's just ping that address and see if it works. Ping 10.0.0.45. Okay, I feel like that's actually an external address. What if I type it into my user bar 10.0.0.45? Okay. Here, let me. I don't know how to connect through here. I think that might just be the address we're supposed to use, and I think we just got to deal with that. Yeah. I think we will just have to live with that fact, maybe. Full stop. As I'm revealing right now, I don't know networks. I'm not a network guy. I've never understood it that well. It's something that I definitely need to like get better at, but I also, haven't had that much need to. So, okay, so we'll import the socket library, import the time library, because we'll need to do some delay. Because, what's it called? It's working at 2400 baud, which is very slow. So we'll have to add in some delays, and sorry about that. And I don't know the ports, so we'll say ports equals, and why don't you like time? Okay, whatever. Ports is gonna be, I don't know, port 23, 23, 064. I asked AI for the ports to guess. Um, for port imports, try, and oh my God, why is oh God, the zoom has it all messed up, guys. Oh my gosh, how horrible. Let's zoom out a bit. Try print F. Why is it stuck? Oh my God, this sucks, guys. Config neovim nvim, nope, not COC settings, init dot lua. I want to just like turn my whole Python autocomplete stuff off. Oh my God, am I using what? Oh, I'm using fennel. Oopsie. Config nvim init dot fennel. Oh, da, 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 da. Close out of that. And okay, we want. I want my language server off. How do I turn my language server off? I wonder. Hmm. That's so odd. L. Do I have Mason? Am I using Mason? Whatever, man. Here. We're gonna say S equals socket dot create connection to that address, which is over here, to 10 dot 0 dot 0 dot 45. And I guess I don't know. I'm not really revealing anything public because it's obviously a private network. Um, IP to the port. Why are those menu boxes still open? Config nvim. What else is in here? The init.fennel? Fennel completion route files, useful fennel macros. Okay, that's all tangerine stuff. And is it Lua line? I think it's this. Wait, no, Lua line is the bottom thing. It's the like status bar. Should I just turn tree sitter off or COC off? That might be for the best. Yeah, I think that's better. Okay. Now let's. There we go. Okay, so we're going to create the connection to the port, and we're trying a couple different ports. And if we'll call this establish connection, and it'll just return the socket that we create. And in fact, now we can zoom in. So we'll try to create the port, and then return s accept exception continue. So we want to ignore all the all the errors. Continue. Raise exception. Couldn't. Oopsie. Couldn't connect. Okay, and then we'll just try to establish connection. Python control.py. Okay, so I ran the script and you heard that. You heard it start ringing. You heard the modem start ringing. Um, and it just worked, I think. Um, yeah, let's give that another try. Let's give that another edit. So it was able to. You heard the dial-up noise. You heard the dialing noises. Um, oh, what on earth happened here? List. Okay, run. So I hit run. It's listening on the network. I'm running my program again. In fact, here I can move this window over here. Da, 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 da. Okay, so now my coding window is on. Oh gosh, my coding window is on the right side of the screen here. I don't know, horrible modem noises. Let's. Okay. So yeah, we were able to do something to it. I don't know exactly what. It's you can see it's writing some junk up on top. On the top left, you can see that there's new junk characters there. And I forget also what the break. Oh, okay. Oh goodness. We've turned it. Okay. Layer reset. BRK. Okay, I seem to have broken my Commodore 64. Okay, we're back. We're back. um, let's rewrite the program just again. But let's do something more substantive with it, okay? We opened up the socket, and we'll have to encode stuff as ASCII. But anyways, and by the way, here, let me give a big credit to a bunch of this stuff. Man, this blog right here. Let me see if I can find it on my computer. Retro Game Coders, Commodore 64 Network. Boom. Okay, C64 plus Wi-Fi. This series of blog posts has been just incredible. It's an incredible series of blog posts. It was super useful. It's where I've cribbed a lot of this stuff. They were at a Python telnet server. Like here, it might even be linked here. I think it's linked in this one. Ba, ba, ba. Network programs connecting. Fork here. Yeah. So this is a simple, what's it called? Python library that Python program rather that does a basic BBS, and he includes is a function here that converts to PETSCII, which is consciously for ASCII. But anyways, credit goes to Retro Game Coders. A lot of this credit, for sure, especially. Okay. Anyways, back to the main scene. Let's keep writing the program. Okay. If name equals main. Yes, I know. Python cringe. Run main. Okay. So def main. And we'll say socket equals sock is this. And what we want to do is, and we want it to fail. If it fails, just to be clear, we raise an exception at the end, couldn't connect. If it can't connect, we want it to just quit. So we'll say with sock. We want to print some stuff. Okay, we'll say our message equals, and it has to be uppercase eventually. So the message is going to be 10 print hello from Python. So it'll do that. Hello from Python. Um, hmm, let me think. Okay, hello from Python. Yeah, new line 20 break. Or how do I exit a program again? Shoot. How to exit program Commodore 64. Stop. Okay. Or yeah, basic command stop halts the execution of a program. Perfect. Line 20, stop. And then I also want to say run and hit enter. So that's our message that we want to type in. So we can say, so with our network socket, we can say sock.send all the message dot uppercase, just in case. And we want to encode it as ASCII, because right now it's Python strings are UTF-8 by default, not ASCII by default. And there's a number of issues with that. But the big one, the not even big issue, but like the issue is that the Commodore 64 can't, it can't understand that. And then I guess that'll be the end of the program. So let's do this. Let's do it. Let's rewrite our little listener program. So 10, we want to open virtual device number 2, 0 at our specified baud rate of 2400. 20 print waiting for Python. And then 30 get from device 1, right? That's the number 1 we specified in that open command. We want to put that into variable a $. If a $, equals nothing, then go to line 30. We're just going to keep asking for characters. On line 40, we're just going to print it out. We poke 631 with the value a $. Then poke 198, and we say, hey, we have a keyword here. Do the key press. And then go to 30 and just keep listening. So we have our device open, and let's see if we can do it. Okay, so it failed, but it says a bytes-like object is required, not str, because I put the encode on the wrong side. So D to the end, paste, go again. Okay, horrible modem noises. Sorry, I'm thinking. Here, what if we break? Forget how to break. Oh man, that's backspace. Is it like F1 or something? Oh gosh, what's the run stop key? Shift clear? Oh, never ran it. Oh my god, I'm so stupid. Okay. You know what? Okay, we have different output on the top of the screen. So I think I'm happy, maybe, with what just happened. I can't tell. Oh, that's hilarious. I have no idea what just happened. It's not printing anything. Oh man. Okay. Okay, so here's what I want to do. I want to print a clear screen. So what is the okay, Commodore 64 PET ski clear screen. Oh, I misspelled screen in a crazy way. PET ski code listing. Okay. Pet cat C64 list. Peak poke. Decimal slash hex. Okay. Okay, yeah, I want this command right here. I want hexadecimal D3, or it's character slash ASCII. I want hexadecimal 9.3, I believe, is what I want. Um, how to send a single byte with Python socket. Okay, so I can do a hex value like that. Okay, so let's go over here, re-edit the program. And low-key, I wonder if just changing it to B in front of it will make it work. Okay, bytes has no... Oh, wait. Bytes has no encode. Goodness. Function. Did they mean decode? Okay. Um, print on socket S. Or port S. Sorry, I didn't want to get some diagnostics in here. Port S. Okay. Um, got an F string. Q normal encoded as ASCII. And low key here, we can do that. I just want to say sock.send. I want to send the byte backslash hexadecimal 9.3, I think. And I think that's what I want it to be. Pesky code 9.3, and then I'll try D3 afterwards if that doesn't work. So all I want this program to do is I just want it to clear the screen and go. And for the record, it's port 23, I guess. And, okay, so I'm not sure what is happening exactly. Um, because I don't know how to write programs for this whole this network stack. Um, hmm. I'm wondering if I need to write in manually some kind of like handshake. Although it is typing stuff on the screen, like there's data coming down the wire. And in fact, it's also like, hmm, it's printed gibberish, but it's supposed to print a clear screen. Um, no rhythmic chirping. Here, I have an idea. What if, okay, so we had these two modes, hardware. What if we change it to UP 9600? And here, we might want to do a quick reset for that. Um, okay, let's open 120 CHR 8 20, and we won't 20 print waiting for Python 30 get from device 1 into variable a a if you are equal to nothing, then keep looking. Otherwise, in line 40, we want to print print the character with no space, poke the character into the virtual keyboard as ASCII, and then poke 198, saying, hey, we have a key in the wait. And line 50, go to 30. Okay, list open, wait for Python. Oh, I did the get. I did the wrong thing. Okay, so it's now waiting for Python. Um, hmm, sending a whole message. Here, let's just try to run the program and see what happens. Okay. It printed something on the top left, and then on the last like static, it went and printed. Rang, there was static. Okay, I want to find out how we can get connected. Hmm. I'm not sure. I'm gonna ask AI. Okay, it says it wants us to turn our baud rate down to 300. Okay, sure, man. I guess I can do that. Modem 300. Okay, reset and save. Okay, so we have our modem all set up. Okay, when we have our program here, we just want to go up here and change it to 6 into a lower baud rate and run. Um, oh, oh my God. Oh my God. You saw that. You saw that, right? It cleared and then it disconnected. Holy crap. Oh my gosh. Yes, that's so cool. No way. Wow. Wow. No way. Oh my gosh. It's okay, hold on. Let's do a more sophisticated program now. Okay. Okay, so for character here. Actually, you know what? Here, let's start off by clearing the screen and then for character in message dot upper dot encode as ASCII. Wait, that is what we did, right? 9.3. Yeah, that's the CHI, that's the hex. Okay. Encode as ASCII sock.send character. I think this so it'll say hello from Python, stop, and then we'll run the program. I think that's it. And then I think oh no way. I think this might work. I think we want to add a little bit of a delay, like a 0.1 second sleep. Okay, let's run it again. Okay, and the Python had a syntax error. I needed a colon at the end of the line. See, if I had my okay, so it said ring, connect 300, no carrier. Okay, so that's pretty promising, I think. Okay, this is bytes like object is not. It is not. Uh, running and low key. Low key. Also, wait, a sock.send character. Um, um, ASCII encoded string in Python as a bytes object other than standard str. Encode ASCII. Socket expected bytes. What is it? What's the error message? Socket expected bytes like object. object, but got int. Okay. Man, I guess 2 bytes, length 1, character 2 bytes, length 1. I think byte order is big, but I'm gonna leave it as default and see what it gets up to. Ringing. Oh my God, wait, look at that. Look at that. Print hello from Python, 20 stop, run, no carrier. No way. Okay, well it didn't enter the okay, so it printed the characters on the screen, but it didn't like save them the way I wanted them to. Wow. Wow. Okay, so let's look at the program again. Control.py. Oh, this is so cool, guy. Holy crap. Okay, I want to do sock.send. What was it? Oh gosh. Bytes, bytes, hexadecimal 93, wasn't it? Um, yeah, 93. And then I also want to I want to put like a long sleep down here for like 10 seconds, just so it doesn't like hang up immediately. So it calls. It should clear in a second. Maybe it'll clear in a second. Oh, nothing. It says ready. Oh, it might. Oh, that's because our program's not running, isn't it? What a fool. Ring. Cleared. Printed the program. Okay. Wow. Wow, wow, wow. I think that's so cool. Okay. Now, all right. Let's list the program. And okay, it's still doing that. Um, so okay, the issue is that whenever what I'm trying to get it to do is to like type the characters in and use that as the oh god. Let's get out of that. And I wanted to like basically use that to write a basic program. Like I want to send a basic program over Python. And then line 50, we'll make a new character v equals ASCII a star $a, because I think what's happening is the $a is getting cleared or something like that before what's it called? And then poke 198 with the value 1. And then, okay, Gemini is telling me to use this command wait, and I don't know what that does. Let's look at what wait. does. Wait. Oops, open it up. Wait, memory address, and mask. Keyboard checks. Oh, beautiful. Wait till 653. Poke 198 with 0. Wait. Okay, yeah, so wait. Okay, yeah, so this is, it literally gives this as an example. To like poke keyboards stuff in. Perfect. Okay, so we'll poke 198 that, hey, we need to eat a key. And then wait for 198 to be 0. That is what it said, right? So we'll wait for it to eat the character 0, and then 70, go to line 30, run. Okay, so say waiting for Python, run the code again. You've dialed the C64. The noise never gets better, guys. We've dialed the C64, and now it should start sending characters in a minute. Or it should hang. Or it should make the Commodore 64 completely unrunnable. Okay. And I think I see the issue why. You look in the middle of the screen, okay? Wait 198 0. I think it should have been wait 198 1. Not 198 0. Oh man. Okay. Okay. Let's try this again. Okay. And also, okay, let's close our device and then open it just to make sure that it's nice and clean. And it's 6 because we have a crazy low baud rate. 20. Get from device 1. A star, a dollar sign. If a dollar sign equals quotes, then just go on a loop. Otherwise, print a dollar sign. So we'll print it to the screen. And then oh goodness, equals. So we'll get the value of it. Start off, we'll get the value, and then we'll poke that value in 631. And here, let me look at the thing here. If this example is given in direct mode, example keyboard checks. This will wait for the Commodore key to be pressed. Try this one in direct mode. When pressing return after you type the command, hold down the return key for a while. I notice how the ready prompt and cursor didn't appear until you press release. Address 3 holds the... so, okay, so if I do wait... If I do wait 20364, it won't release until it's done. Wait until a key is pressed on the keyboard. Internal clock location is stored there. Incremented every 60th of a second. Okay, Loki, I don't think we want to do any of this wait stuff, but I do think we'll do this V stuff. 198 1. So take a character, COM64. and then go to 20, run. Okay, so there's no print, but I know the program is running. Type away, Python. Ring. Static. Okay, now it's taking characters. Okay, and it said no carrier. Okay, so it's not taking. Oh, man. Okay, let's. All right. All right. Commodore 64 keyboard map. Memory map. Okay, the memory map. Cartridge ROM. Basic RAM. I think we want the ROM table, not cartridge ROM. VIC2 registers. Nope, that's too high. Okay, there's a text called mapping the Commodore 64. And okay, I know that we're working with address 198. Poke 198. 1984. Okay, the value returned here. The value's here. 198, number of keyboard characters in keyboard buffer. Okay, so 631, we poked the thing into 631. So we poked into 631 the value, and then we say, hey, there's a character here. Run. Okay, let's try that again. Okay, so it printed saying my thing, and then it's not actually running it though. Okay, let's edit the Python program. And do I need to like send sock.send the byte return new line? I don't know. Go again. Okay, I turned it down. I think it should be quieter from here on out. But all right, so it printed. It did 2 more lines. Okay. Let's find out what the return key is in like bytes, and let's send it in bytes. I don't know if \r is working. Yeah, okay, it's gonna be up here. Home. Place current in the top left. Turn reverse on. Move cursor down 1. Press return. Okay, return is 0D. Okay, so let's write that in our Python program. Send x0d. Wait. Here, low key. Okay, we'll make message. It'll be like each line is its own thing, its own string. And then after each line, I'll press what's it called? I'll do the what's it called? The manual return. 20 stop next string run. Print hello from Python run 20 stop run. All right, that's the message array. All right, for message in messages, we want to send for every character encoded as ASCII, and after every message, sock.send a byte that's, oh gosh, which one was it? 0D, I think. Press return. Yep. 0D. Okay. So we're accepting input. Run. Okay. All right, it's much quieter, much more pleasant on the ears this time. We're saying ring, connect to 300. Okay, print hello from Python, and then it's doing dash. It's a large dash, actually. Okay. That's wrong. No carrier. All right, where is large dash? Oh, wait. Press return, yeah, 0D. Delete character before position. Hmm. Control F. Return. Hmm. Yep, it's still saying return is 0D. I wonder, hold on. Is it distinguishing somehow between like capital D? I don't know. Let's try it. Or wait, what's the decimal? Um 13. 13. No, whatever. Okay. Let's run it again just to see if it changes. All right. It's sending long dash, not the return key. Long dash instead of return. Okay, well now it's just the letter D. Did I mess it up just tremendously? Yeah, it's sending 0 and then D. Oh, it's 0x. It's gotta be 0x. Oh man. Okay, let's do one more time. One more time. Go again. Ringing. Yep. Noises. Connect 300. Print hello from Python. 20 stop run. But it's not running the program. Why is it not running the program? Hmm. I wanted to basically like I wanted to basically treat the serial device as a keyboard, or like my network device as a keyboard. Um, Hmm. I don't know. Hmm. I don't know, guys. I don't know. I'm sorry I keep going silent. Man, what bad content I'm making. Okay. Hmm. You know what? I wonder. This might be funny. Um, Here, let's write a Python program real quick. Instead of a subject section, I'll say while true, foo equals input, print foo dot encode ASCII. Actually, you know what? No, wait. Instead of all this in our socket, what if here? I'm gonna comment out a bunch of this stuff. Okay, while true, foo equals input. So we'll input, take some Python input, and then we'll say for character in foo dot upper dot encode as code as ASCII. Sock dot send. Send versus send all. I wonder what the difference is. So I know that both exist. Um, Whatever. Let's try send all. Um, Send all character dot encode uh, ASCII, and I want to couple the encoding here, whereas that's just string logic. Send all time.sleep, what is it, 0.1 seconds? And then after each input, we want to send a return key, and it looked like it was just doing the same thing, but we'll do this manual return nonsense stuff here. 0D, Python. Okay, it's still establishing the socket. Okay, so we've dialed in, and now we're waiting. So I'll say 10 print hello from the computer. The computer. 10 print hello from the computer. Um, okay. Okay, that seems pretty cool. Um, Maybe we say mm, run. New line 13. Alien basketball. Cancel. No carrier. Okay. Um, hmm. All right. All right. Hmm. What I'm wondering is like how's it able to display the character but not um like virtually type it in? Like that's what I'm kind of wondering. Hmm. Okay, it needs to be in immediate mode. Must be in program mode. Okay. So we have a much longer program. And I asked AI to write this for me. So we'll see if it even works. So it's for the most part what I've been writing so far. Yeah. And we initialize a nice empty string up here. And then we'll start off with our get one, a dollar sign. If a dollar sign equals nothing, then go to 20. Okay, but if we get a character, what we want to do is print it out, show what we're doing, show our work. We'll make the B string into the old B string plus the A string. Um, and then go to 20. I'm seeing an error with this. Was because it's just an infinite loop on 20. Um, yeah. Okay, so we'll print that, and then if the ASCII of a dollar sign doesn't equal 13, so if it's not a return 13, then B dollar sign equals B dollar sign uh, plus a dollar sign and go to 20. And then the sort of else is going to be 40 if B dollar sign is nothing, right? So if the line is empty, then go to line 20. But otherwise, goodness, for I equals 0 to the length of B, we want to poke 631 plus I minus 1 with ASCII and we're gonna get the character at B in order to type it in. So we'll type in the whole buffer all at once. And then last but not least, we're going to add in the return value character, but we're going to do it manually here. And then we're going to tell it, hey, you have this many characters. B $, plus the return key to read, to type in, and on line 70, reset B $, and wait 198, 0, go to 20. Wait for it to be done and then bam. So, okay, the program is running. I'll run my program, which it should, illegal quantity error in 50. Okay, for I equals 0 to length B $, poke 631 with ASCII, the mid BI1. B $I1. Which one was the for that to that next I? What would be the quantity error? I didn't send any data yet though. Run. Who? Bar. Print. Hello. So I'll hit run. Say run. Okay, it's able to send it. It's doing it correctly. Like, wait, okay. So, all right, so it's closing the device, opening it at the correct baud rate, getting the keyboard, printing it. It says, okay, it's not a new line. It's saying if it's blank, then go to 20. Okay, it's not blank. And then it says for I to the length of B $. It pokes that with that. Okay, so I think the wait might have done something magical here. Let's just make a new program. 10, close 1, open 120 at the right baud rate. 300 baud or 300 baud. Oh, not 600. Just 6. Okay. Get #1 a $. If a $, equals blank, then 20. And then I want to show it on screen. So print a $, with nothing at the end of it, 40. Now I want to poke 631. We're going back to one character. If you hadn't guessed. Poke 198 with 1. And let's make sure. There we go. Line 50. We want to wait for 198 to be clear. So we wait for it to process the character. And then we go and listen. Oh, and then we listen for a new character. So we're listening. We're establishing a connection. Thank you, modem. Okay, so I'll say like print hello. 10 print hello. Okay, so I broke something. Get from device one a dollar sign. If a dollar sign is equal to 0, then go to line 20. Print a dollar sign. Poke it into 631. Tell it we've got a key in the waiting, and go to 20. Okay, so it's taken command of my keyboard. What if I try to redial it? I think that wait 198.0 might be screwing us. Yeah, I think that might not be working. Run. Okay, yeah. We'll reset again. Ain't no shame in the resetting game. Hmm. Hmm. Okay, let's get rid of the delay. Open 120 character 6 20 get 1 a dollar sign. If a dollar sign equals blank quotes, then go to line 20. Otherwise, print it with nothing after it. Also poke it, poke the ASCII value into 631. Say, hey, counter 64, got something for you. And then we'll do a manual wait. And then finally loop. And let's change our Python program back to this, the old like messages program with the manually set, you know, thing. And while we're at it, let's do, as soon as we connect, let's do like a time.sleep for like 3 seconds to say like wait for connection. Like I don't want the noises to be happening while it's doing this. Ah, okay, well, I'm curious to see what happens. I don't think it'll do anything because I didn't hit run on the program, but that's whatever. Okay, yeah. So let's run it. Ring, beautiful. Doing some negotiations. Connect 300. Print hello from Python. Stop, run. Okay. Still, man, still no dice. Man, I wonder if this is even possible, what I'm trying to do. Like, I wonder if I have to manually switch to immediate mode or something else entirely. Um, hmm. Hmm. I don't think the keyboard buffer is working, right? Like this line here. Poke 631 ASC a dollar sign. Hmm. Immediate mode in Commodore 64. Executing commands from within a program. Commodore 64. Okay, wait. The short answer, I want to write a very simple basic program in Commodore 64 that enters other basic commands. Here's an example. 10 print list chr dollar sign. Yep, okay. My expectation is that I get the result of the command list. How can I achieve this? Okay, yeah, this is exactly what I'm trying to do. Okay, so this is saying, man, it's saying that the keyboard buffer approach is correct. Yeah, keyboard buffer, Commodore 64 keyboard buffer tricks, deleting and creating basic lines from basic. No. Oh, okay. Internet Archive. Please be archived. It was on Stack Overflow, so surely it was archived at some point. Okay, yep. 2019. Give me the snapshot. And I'm gonna go tab away from it. I'll BRB just in case there's something evil on this page. I don't want to see it. Okay, it looks like a fairly normal website. Okay, let's do it. Let's look at this page. All right. So the keyboard buffer is only 10 key presses long. Um, but we can't get any more than that. Something more advanced. Since basic lines can be deleted from direct mode, why not try to delete basic lines by using the automatic methods we have just seen? After all, it's just a matter of printing a few line numbers on screen, then cleverly use the keyboard buffer to make the program automatically hit return over those line numbers. Well, it's a bit more than just that. Okay. Creating data lines. Oh, okay, this is what we want. This is what we want. Okay, I'm gonna be right back. I have to go pee, but I'll be right back and then I'm gonna tinker with this for a second and then I'm gonna end stream. Okay, I'm back. I also grabbed a handful of candied ginger, but okay. This website, it feels very promising. Hmm. Hmm. Okay. Hmm. Let me think. From okay, it wants me to download this file. Oh gosh, please have been okay. It was saved. Man, how do I read the code though? We issue the following line from direct mode. The word ace will appear, like if you typed it. From direct mode, assign a variable to a value other than 0. Then try to delete a line number, let's say 10, even if no program is on memory. Now print the variable that you've previously assigned a value. You just get 0. The previous value has gone. Is that true? A equals 1. Print A. 70, go to 30, print A. Huh. Why has that happened? When you delete a line, the basic interpreter must resize the whole basic memory, including both the program and the variable storage area. As a result, variables are cleared. That's an insane. Wait, pause. When you delete a line, Basic has to resize the entire memory space. Oh my god. Wow. Okay. Anyways, so we can use this keyboard buffer technique to automatically delete basic lines, but we must be careful because we have this program. The idea is to use a basic program that will live along with the basic program you will write. Lines above 60,000 are seldom used by programmers. So those lines are reserved for some basic utilities. Of course, you may accidentally delete a line that is part of those utilities, but we will take this risk. After all, we are just demonstrating some tricks dealing with the keyboard buffer. Okay. Well, this is promising. One way to execute basic commands is to build a string and then manipulate the keyboard buffer. Print chr 147 17 17 17 cm $. Poke. So, okay, clear the screen, cursor down a few times, then print your command in cm $, onto the blank screen. Poke return, followed by cont, followed by another return into the keyboard buffer. Tell the system that there are 6 new strokes in the keyboard buffer. Move the cursor to the top of the screen and end the program. This is where the magic happens. The C64 will begin processing the characters in the keyboard buffer. To test the subroutine, add the following lines. List, go sub 100. Yeah, it's maximum. Okay, so, okay. Okay, I think this is possible to do. I really do think it's possible. The issue is hard. um, tell you what, I'm gonna end the stream here. We've done 2 solid hours of grinding and getting connected to the Counter 64, and we can just send stuff over Python. That's awesome. Um, we can build strings up, and if we can build strings up according to this website and the Stack Overflow page, we can execute arbitrary code. So I think that's where we'll end things. Thank you for watching. I've been Patrick. I've been Code Orangutan, also known as Patrick. Have a good night.